The block diagram of the variable speed drive or the variable frequency drive. We've got our 3-phase entering the system, and that goes to my rectifier. The rectifier's purpose is to convert the 3-phase AC into 3-phase DC. In other words, we're going to have 3 DC values. The rectifier feeds into the regulator. The regulator's purpose is to convert and ensure that all 3 of these 3 phases, although they are DC now, have the exact same value, and those 3 single DC phases will then feed into a inverter. The inverter's function is to convert the DC back into AC, but at a different frequency than the input frequency was, so that we can use it to control the speed of the motor. The inverter runs on the principle of analog to digital conversion and digital control. Okay. This is also called sigma delta conversion. Basically how this operates is when it comes to the regulator and this inverter, it's also called a modified sine wave inverter. How that operates is instead of converting the DC value, into a sine wave, what the analog digital conversion and digital control system does is it takes the DC, that value, and it converts it into a string of pulses. And by the rate at which it turns on and turns off. In the inverter, we will have a capacitor that has the ability to charge. So the longer the pulse is introduced onto that capacitor, the more that capacitor will charge. So we will get a modified sine wave generated instead of a pure sine wave. So the string of pulses will then generate the sine wave. Types of motors that are used with variable speed drives. These are DC motors, as long as they are connected in the universal mode. Split phase, capacitor motors, squirrel cage or induction motors, basically any AC motor that has the ability to connect to a high voltage source.